Good morning, everyone. I'm very pleased to give a talk about my research that we conducted in Brooklyn College Soil Research Lab together with my lab colleagues and professors, Joshua Chen, who is present here, Mahadip, our postdoc from France, Zulema Garcia Blanca, who is our undergrad student at Brooklyn College, Sarah Pearl Eggendorf, our PhD student who will also present later today, and Peter Grafman, for some of you very well known soil ecologist. So, as you already know, urban soils are often contaminated with lead and arsenic. And recently, phosphate amendments are being promoted as cost-effective means of reducing lead hazards in soils by forming lead phosphate minerals that are known to be very stable. The magnitude of this effect is not well understood regarding to lead and arsenic uptake by plants. When we add phosphates to soils, arsenic becomes mobilized and it causes some issues. There are three main contaminant exposure pathways that are known, which is the leaching through groundwater, exposure through ingestion, inhalation, dermal contact, but also it's through plant uptake. And this is what my research talk will be focused on today. Plant take through crops, food chain that will end up in our human bodies. Here are some hypotheses that drove our research. The type of amendment effect of concentration of lead and arsenic in plant tissues. The type of plant affects the concentration of lead and arsenic in plant tissues. And we were looking if there is correlation between dust and splash and vegetable lead and arsenic. Our site studied was in New Jersey. It's an urban farm, and it's known for past pesticide lead and arsenic pesticide use. It's a former orchard with lots of lead and arsenic. And here we have some selected soil properties presented. It's a fine soil, silty loam with low, slightly acidic pH of 6, medium total organic content about 6%, total phosphorus was about 700 ppm, total lead 300 ppm. Just to remind you, EPA threshold is about 400 ppm. We also measured total arsenic, which was very high here. It's about 4.5 times greater than EPA threshold of 16 ppm. And here are my beautiful plots at the beginning of vegetation season. We had 25 plots, and each plot was treated with different amendments. Here we have spinach, lettuce, carrots, radishes, eggplants, and tomatoes. Unfortunately, something ate our spinach, and potato bugs ate our eggplants. So we end up with radish, carrots, tomatoes, and lettuce, but they still gave us really good results. And here's the schematic representation of our plot. It's a really big project. We have 25 plots with amended differently, each of them. And if you look in the columns, you can see that every plot, it's about 4 foot by 4 foot, with 2 foot in between. Every column represents different amendments. So control, the first row, the first column is control soils, then it's a bone meal with a 15% of phosphorus. Next we have triple superphosphate with a 46% of phosphorus. And we also amended soils with manure compost and raised bed compost that came from Home Depot. That's something that any gardeners can purchase. We also look at different treatments based on in the rows. You can see that second row with the double treatments. So basically we doubled the concentration of single treatment from previous row. We added iron, manganese, and iron manganese together in a further plot. And the reason behind it is some research say that will enhance formation of paramorphic mineral, and we will try to see how it will affect concentration of lead and arsenic in plant tissues. Another part of research which is results that is not presented here is bioaccessibility. So next time we will meet, I will tell you about bioaccessibility of lead and arsenic in those plots. And some results that we found, I will not go into too many details about statistics. The main purpose here is to say that the primary effect was due to plant type and then due to amendments. So lead, arsenic, and vegetable lead and arsenic concentration really varied in the plant types. And if you look close on each species, we will see that on the x-axis we have carrots, lettuce, radish, tomato. Y-axis represent vegetable concentrations and fresh weight. And for lead, we see that carrots exceeded all threshold, and red dashed lines represent threshold from European Commission guidance values. Unfortunately, the United States of America don't have their own guide values, so we had to rely on international health-based standards. Then the lettuce and radishes also exceeded some thresholds. For lead, tomatoes were very safe, extremely well below the threshold. As you can see, that carrots much significantly different. The value is significantly different from lettuce, radish, and tomatoes. And if you look in arsenic on the right graph, you see that mostly it's consumed by arsenic is in radishes, followed by lettuce, carrots, and tomatoes. All four groups are significantly different. And the threshold here was used from Chinese guidance values. Now we look at the effect of amendment type, which is, as I already mentioned, is of secondary importance. So what happens here is that addition of total organic content will increase biomass, and pH will be also improved close to neutral, which together will affect soil and vegetable lead and arsenic concentration in soils by dilution effect. In the future, it will have a primary effect, because if we improve soil quality and soil health, it will be more important, and we will be able to grow any types of vegetable if we meet all these expectations. So more organic content and more biomass will lead less vegetable and lead and arsenic. We look at each amendment type to see how it will affect vegetable concentration. And we will see on the x-axis we have bone meal, control, manure compost, raised bed compost, and triple superphosphate. A y-axis represent again vegetable concentrations. And for lead, 95% of confidence based on ANOVA test that bone meal was not different from control, but all other treatments were significantly different, telling us that it indeed reduced amendment, phosphorus amendment, reduced vegetable lead concentration. And if you look on the right graph with arsenic, there was no effect of amendment on arsenic lead concentration. We also did a third approach, third analysis, a linear discriminant analysis, to see really which amendment is the best to apply in this kind of soils. And we see here, so if you look at each quadrant is correlating here in the circle and on the right side of the graph. So if you look on the bottom right, control, maybe hard to see, the color is light, but it's mostly, you will see soil lead, high concentration of soil lead, soil arsenic, vegetable lead, and arsenic in control soils. If you go to the top right, with bone meal and triple superphosphate, we see that we have more phosphorus, which will which leads to more vegetable arsenic release if you look on the circle. And on the left side, manure compost and raised bed compost. It's compost, so we have more organic matter, which will increase, which will give it a dilution effect, and biomass of produce was much greater in those composted treatments. So we found that compost was the best amendment for reducing vegetable lead and arsenic concentration due to increase of total organic content and biomass. And if you see in the circle, this actually has a negative effect between total organic content biomass and of plant lead and aluminum. Plant lead and arsenic. What really affects, what is the source of lead and arsenic in those soils? Where it's really coming from? Is it due to uptake or something else? And this PCA help us to understand this is not due to uptake, but actually due to adhesion between dirt particles on the plant tissues. We have some positive correlations between tissue lead and tissue aluminum. In the next slide, I'll show how high correlations are those. We also see some correlations between soil lead and tissue lead. R squared was quite low there, except for carrots. Carrots are known for actually uptaking lead because of the core inside. So it's basically like sucking in lead. For soil arsenic and tissue arsenic, the correlation was also very, very low. So we looked more closely at vegetable aluminum concentration, which is represented on x-axis, and vegetable lead concentration or arsenic. And we see here that correlations are quite high here, which leads us to the idea that it's due to physical contamination of the plant tissues, basically dust or dirt particles from wind blowing or from splash will adhere on the surface. And the same was found for radishes. Of course, if we take those outliers off from the first top graph, we will have greater concentration, greater correlation. As you remember, we also had a second row with double treated plots, and we wanted to see really if this we need to have extra concentration of phosphorus or compost in the soils. And it found there is no difference. It doesn't matter if you have a single treatment or double treatment. So you do not need to add extra compost or extra phosphorus into the soil. Single treatment will be enough. And effect of manganese and iron was not as high as expected. Manganese actually was quite in toxic levels, and it killed the plant. So last plots did not produce vegetables. Only some vegetables were grown at the end of the season, like radishes, which tell in composted plots, which tells us that we need to look into more compost and manganese correlation. Iron reduced pH in the plots and lead availability increased in the phosphorus treated plots, but it was not observed in compost. So in summary, we have different vegetable types and they will have different concentrations of lead and arsenic in their tissues. In general, leafy greens have less concentration of those metals in tissues compared to roots, but much higher than fruits. And lead and arsenic concentration in vegetables are controlled by dust and physical contamination, and the soil characteristics will also influence phytoavailability. Availability. We found that compost are the best amendments for reducing vegetable and lead concentration and improve plant production. Some recommendation implications on mitigation strategies. We should apply best management practices, plant fruits over roots in those contaminated soils. We also should wash and peel our produce, which will decrease contamination, but still it will not get treated off. Some dust control, like mulch and deep irrigation, will affect water efficiency and weed control, and will eventually mitigate some contamination because there will be no splash and no dust blowing around. And some conservation tillage will be also useful, and some pictures can provide you an idea how it looks like. It's a collaboration between our partners, the NOFA and USDA and RSTS. Our undergrads were extremely helpful in conducting this research because it's a big job on planting these vegetables, amending them, and taking care of them during the season. I would like to thank you for your attention.
We have time time for a quick question. So how much compost did you put down and what was your method of incorporation?
So it was 3:1, just what says in the back, 3:1 by volume, soil, compost soil, and we just mix it thoroughly in each plot.
Did you wash the vegetables thoroughly before
Analyzing them?
analyzing them?
Yes, definitely. We wash them like 3 times at least. And we only analyze the edible parts. So in radishes, we cut the leaves and we got the root. We only analyze the edible part because this is a project for gardeners, for people who get this produce, so we only analyze that part. And we, of course, wash it really well.
So, I guess I'm a little confused. So you think in spite of the washing,
Yeah,
all of the
the-
arsenic and lead was
it's
on the surface?
yes, exactly. So no matter how well you wash, it will still on the surface due to physical attraction, like due to adherence. It will be still there. And there are some other studies who did lab wash with like nitric acid, and they still were not able to get rid of all lead and arsenic. So it indeed sticks on surfaces. And this is the main problem. Yeah.
Did you make any solution measurements to see what was available in the soil solution for the plant uptake of phosphorus or lead or arsenic?
We didn't measure the solution, but we measured micronutrients, like Morgan method, and we also did a bioaccessibility test. And this is my other part of the research that I'm not presenting here. And
I mean, you're looking at plant uptake, right?
yeah.
So plant uptake is driven by what's in solution and available to the roots.
Right, but here it's more importantly with the plant type, and it's not really due to uptake, it's due to adhesion, the physical contamination. The only carrot was due to uptake, it's physiologically suck everything in. And if you look at the concentration of lead and arsenic in soils, it doesn't really correlate with vegetable concentrations.
Did you measure
Last
yield
question.
of the different crops in the different treatments?
Yield, yeah. So in compost, we had much greater produce, like really big tomatoes, carrots, and radishes. Especially controlled, they were really small.
All right.
Thank you very much for your question.